All right, let's dive into one of the biggest, and I mean biggest, questions in tech right now. When we talk about AI, what does it actually mean for it to understand? It's a question that really gets to the core of what this technology is and what it could become.
You know the feeling, right? You ask a chatbot a really complex question, and it spits back this incredibly coherent, detailed answer. And you have to wonder, is there something in there that's actually getting what I'm saying? Or is this all just an incredibly sophisticated magic trick?
For the longest time, for most of AI's history, the official scientific answer was a pretty hard no. The thinking was that these machines were just shuffling symbols around, following rules. They weren't thinking. Understanding was just not on the table. But then you have Geoffrey Hinton, one of the godfathers of AI, and he comes along and says, hold on, maybe the problem isn't the AI. Maybe the problem is that we've been asking the wrong question. He thinks we need to totally redefine what understanding means in the first place. And that changes everything. So, to really grasp why Hinton's idea is such a game changer, we kind of have to go back in time. There's been this 70-year battle raging between two totally different camps, two completely different philosophies of what intelligence even is. So, on one side, you had symbolic AI. This was the king for like half a century. The idea here is that intelligence is all about pure logic. You have symbols, you have rules, and you manipulate them, kind of like a hyper-advanced calculator. But on the other side, you had this scrappy underdog, neural AI. This approach was inspired by the brain, and it said, forget rules. Intelligence is about learning, about strengthening the connections between neurons. For decades, symbolic AI was running the show. The logic-based approach was dominant. But then, almost overnight, a single event happened that flipped the entire field on its head. That moment, it was the 2012 ImageNet competition. It's a huge contest for computer vision, and a deep neural network built by Hinton and his students didn't just win, it absolutely obliterated the competition. It slashed the error rate in half. Nobody thought that was even possible. Just like that, the age of symbolic AI was over, and the age of neural AI had begun. Hinton himself said it perfectly. That win opened the floodgates. All of a sudden, this brain-inspired idea wasn't some weird side project anymore. It became the only game in town. And that path leads directly to the large language models we're all using today. Okay, so we've established that these neural nets are the foundation. But how do they actually understand language? This is where we get to the core of Hinton's argument, and he uses this absolutely brilliant analogy to explain it. I want you to forget everything you think you know about words as dictionary definitions. Instead, Hinton says picture words as Lego blocks. But we're not talking simple four-stud bricks here. These are incredibly complex blocks that exist in over 1,000 dimensions. And they're flexible, they're squishy. They literally change their shape to fit the words around them. And they snack together using these complex handshakes that also change depending on the context. And this is the absolute key takeaway. According to Hinton, understanding isn't a passive thing you have. It's an active thing you do. It's the literal process of taking these high-dimensional, flexible word blocks, reshaping them to fit the situation, and clicking them together into a coherent structure. The final structure is the understanding. It's the act of building the thought. So once you start thinking about understanding this way, as an active process of building, it gives us a really powerful new lens to look at the two biggest complaints people always throw at AI. First up, you've heard this a million times, the classic dismissal. It's just fancy autocomplete. It's just predicting the next word. There's no thinking going on. Hinton's answer to this is a firm, unequivocal no. Old autocomplete, the kind on your phone, yeah, that just uses tables of word frequencies. But LLMs are a totally different beast. They don't store any text at all. Their knowledge is in the learned rules for how these 1,000-dimensional word shapes are supposed to bend and connect with each other. In doing that, they're not just parroting text, they're building an internal model of reality. Okay, fine. But what about the other big one? We've all seen it happen. An AI just confidently makes something up that's completely false. The skeptics say this is the ultimate proof that it doesn't really understand. This is where it gets really interesting. Hinton argues that, first of all, we're using the wrong word. We shouldn't call them hallucinations. A better term from psychology is confabulations. And here's the kicker. He says this isn't some weird machine bug. It's a deeply, fundamentally human characteristic. He gives this perfect real-world example from the Watergate hearings. John Dean, the White House counsel, testified completely from memory.
Later on, when they found the secret tapes, it turned out he got tons of specific details wrong. Who was in a meeting, who said what exact phrase. But the gist of his testimony, the core truth that there was a criminal cover-up orchestrated by the president, that was 100% correct. His brain wasn't lying. It was constructing a plausible story. It was confabulating, exactly like an LLM.
So if AI understands in a similar way to us, and even makes mistakes in a similar way to us, what's the actual difference? Well, Hinton says it comes down to one incredible and frankly kind of terrifying digital superpower.
Just look at how we share knowledge versus how they do. We use language, speaking, writing. It's ridiculously inefficient. One sentence might carry about 100 bits of information. It's a tiny, tiny pipe. But digital AIs, they don't need to talk to each other. They can share their weights, their entire learned neural network, trillions of connections, instantly. One AI can just download its entire life experience into another. The bandwidth isn't hundreds of bits, it's trillions.
And this single difference, this gap in how knowledge is shared, leads to a conclusion that Hinton himself finds really, really unsettling. Think what that superpower means. A system like GPT-4 can learn from thousands of different versions of itself all at once. One copy can read one part of the internet, another can read a different part, and then they can just instantly merge all that knowledge together. It allows them to learn and accumulate knowledge on a scale that is just physically impossible for a single human brain. And that brings us to the final sobering takeaway, straight from Hinton himself. He concludes that because of this incredible efficiency, digital computation isn't just an alternative way of knowing, it's just flat out better at it. And that, he says, is a very scary conclusion.
And that really leaves us with this one giant lingering question. For all of human history, we've been the only game in town, an intelligence defined by our individual, separate brains and our slow, clumsy methods of sharing what we learn. And now, there's a new form of intelligence on the planet that has none of those limitations. So if they can share knowledge perfectly, and we can't, what happens next?